Welcome back to the Art of Boat Building. In this episode, Bob carves an oar out of ash for Skylark. In addition, we visit Bob's friend Steve, who's turning a hook handle on his home-built CNC lathe. Stick around to the end for a final update of the launch of Skylark.
I'm just measuring the beam of the boat here, which is 69 inches. Now, the reason I'm doing that is that I realize that I probably am going to need an oar or a paddle in case I get stuck in the doldrums while I'm sailing. And the other thing that I realize I need is a hook in order to catch a mooring. So I have a way to sort out both of those things, but to get started, I decided what I'd figure out is how long of an oar would be needed for a haven. Now, the famous oar maker Sean Tanney have a very good formula for figuring out the length of an oar for the size of your boat. So what they want you to do is to start with the beam. So here, of course, I started with 69 inches. And you divide that in half. So that would be, in this case, 34.5 inches. And then you add 2 inches, which would then give us 36.5 inches. Now that number is called the inboard loom, and that is from the oar lock to the end of the handle. So you take that inboard loom number and you multiply it by 25, and then you divide that by 7. So the number that we end up with is a little over 130 inches. So that would translate into an oar that was over 10 feet long, which is pretty big. Now the plans actually show where oar locks and an oar in the boat. So let's take a look at that and see what it tells us. If we look here on the construction drawing for the haven, a couple of things are noted. First of all, we can see that here is the location for an oar lock, and here it is on the side of the coaming. And this, of course, is where the strongest beam is across there. Now, I'm not quite sure how you're supposed to sit, if you're supposed to sit on the centerboard trunk or what you would do in order to row a boat of this scale. And also, a 10-foot oar is really, really long. Now, the other thing that needs to be considered is the storage of the oar. Now, you can see here in the side plan that there is an oar drawn in here that Joel White added. Now if we take our scale here, now this drawing is 1.5 inches equals 1 foot. So I put my scale on here at 1.5 and I have 1, 2, 3, 4, 5, 6, 7. So the oar is only 7 feet long. So it actually is probably more of a paddle than it is an oar. Now I did not add oar locks to the boat, and I'm only planning on making one paddle for the boat. So that's the length I'm going to make it, and I'm going to use this pretty much as the design for the oar. So the next step is to find a nice piece of timber that I can make that oar / paddle out of, and the stick for the hook. I've got this really great looking piece of ash here, which is completely clear. Now some of you may think, well, ash is a little heavy for an oar, but this is the wood that I have. The other thing is that that's what I used on the tiller. So I think it'd be nice that the wood is the same on the interior of the cockpit there. Now, this is probably an oar that's only going to be used occasionally, so it's not like something that you'd be rowing with a lot, where you'd probably want something like a spruce or Douglas fir. So anyway, I'm going to use this ash because I have it, and it's 1 inch and 3/4 inch thick, 1 3/4 inches thick. So what I have here is a board that is easily, well, it's 8 feet long, so I can get my 7 feet out of there quite easily. So what I've got laid out here are 2 items. First of all is my oar pattern that will sit here, and it is 5 inches wide at this point, and it tapers down at this point to 1 1/4. So it'll taper down and then fatten out a little bit, depending on what kind of design I want it to be. Now this is the hook. This actually was an old hook that my friend Steve Colburn gave to me. I cleaned it up and got most all the gouges and so forth out of it. So that's what I'm going to make the stick for the hook out of the remaining piece here. So I'll cut out 1 3/4 inch piece here so that that can then be turned down to fit inside of that hook. So my first step is to lay out where the oar goes and then get a piece of this cut off. Now that I've got the general shape cut out from the front side here, on the part that the material was 1 3/4 inch thick, I've drawn the same taper on here as there is here. So that's my next step, is to get that cut out. So now I've got my oar blank all trued up and got all of sort of those rough cut spots from the bandsaw off of it. The next thing is to turn the shaft round. And we do that by making it octagonally first. And one of the ways we mark that off is with the spar maker's gauge. Now, if you're unfamiliar with this process, there's a video right here of when I do the whole process of how a spar maker's gauge works. So that's my next step, is to mark off these all 4 sides, and then I will plane down this corner so that I'll end up with an octagonal shape. Well, now that I've got the handle turned down basically octagonally, now what I need to do is take these high spots off and essentially make it 16-sided and get it closer to being round. And I'll do that with my hand plane like so. Now that I've got those high spots marked off, I'm taking this sandpaper. You can see I've made it sort of concave so that it will fit on the convexness of the ore here. And so now I'm just going down and kind of cleaning it up. And you can see that it is very nice and round. Well, now that I've got the handle pretty well shaped, what I need to do now is to work on the paddle end of the oar. So what I want to do is to take this thicker part and keep it thicker along here, and then concave this part out in here and then out to a flat surface out here. So what I need to do first is to figure out where the center line of this is, so that I can then, and then the center line here, so I can start carving or sculpting, if you will, the blades. So you can see what I've done here is that I have drawn some lines here so that I know that I want the end of my paddle here, the blade, to be 1/4 of an inch, and that it slowly taper up. I've also found the center line here on the face of it. So basically what I need to do is to take the material from here, so I want to be flat here, and then I want a ridge in the middle here to add strength to it. So this section here, it needs to be kind of concaved out of there, carved out of there. And I'm going to do that with this power rasp that fits on the end of a right angle grinder. So it has just like a rasp, and it will cut this really nicely and cleanly. I really like this. It's really a very handy tool, especially when you're doing any kind of carving. Now that I've got it all shaped and roughed out with that grinder, what I'm going to do now is use a flap wheel on my grinder. This is an 80 grit flap wheel, and so that will smooth out any little irregularities that are in there. I finished it off using a palm sander, starting with 80 grit, then moving to 120, and finally 220 grit. With the ore completely sanded, my granddaughter Neve helped me burn a maker's mark on both sides of the ore blade. Oh, there we go. So I've got the ore all finished up and ready to go into the boat. Now the next thing you need to turn our attention to is the handle for that hook that I had shown you earlier. So my friend Steve Colburn is turning that handle down on a home-built CNC lathe that he made. So we're going to take a visit to his shop and see how he's working on that handle for the hook.
You can see I didn't do any housekeeping today. And then you can see the lathe.
Yeah. It is a long one.
Yeah, I didn't cut, well, I cut about an inch off, but that's it. I just got it down to where it's round and, you know, uniformly so. But I had to.
And explain what those are for.
I made these first thing because it was so flexible. It wouldn't turn, you know, it would sort of jump around. So I try to keep them close to the carriage. I moved the carriage part of a foot, and I advanced the supports a little bit, and that seems to solve that problem.
Here.
Well, this lathe is probably 150 years old. I got it as scrap for $25 about 4 years ago, and cleaned it all up and used it for wood turning. It's an old metalworking lathe from New Haven Manufacturing, Connecticut, and used it for wood turning for a long time, and was about to do a project where I needed to make some spindles for a porch railing, and got an estimate on one spindle of $43, and I thought, I need 50 of these things. So it occurred to me that with that amount of expenditure, I could put numerical control on this old lathe and make them myself, which I did. And it consists of this carriage with the stepper motor and the ball screw, so it advances in this direction, and another stepper motor that drives the feed along the other axis. So that's the hardware. And then over here in this box on the wall, the power supplies and electronics, and then a laptop. And the laptop has a little program that feeds coordinates into the system, and basically it just follows the coordinates.
So can you show me how the coordinates for the pole for the hook worked out?
Sure.
How'd you work that out?
Sure. In the way I've been doing it, I start out by drawing whatever shape it is I want, whether it's a boat hook or a porch spindle or whatever it is. I draw it in a CAD program, something similar to AutoCAD or something, so you can get a very detailed picture of the shape. And then from there, there's a couple of steps that allow me to extract the coordinates along the perimeter. And just I've got a picture here for the boat hook, which is almost a straight line. You don't see much profile, but what I did, I put it in the program and then expanded the perpendicular axis, the y-axis, by a certain factor, so you can begin to see some shape to it. And this is just expanded out so you can see it. And that allowed me to draw a spline curve. You can see down here, this is the end where the taper goes into the boat hook, and then it's got a little bit of a thickness, then it gets thinner again.
So essentially this is then is stretched out really long, and then you can't see that as much.
Yeah, that's right.
It's really subtle, isn't it?
It's just a way to allow me to get a nice curve without, just imagining it.
So you had mentioned the balustrades that you had made. So maybe you could show that, because it'll be a little easier to show how the change in profile is.
Yeah, one of the things that you see when you look at the lathe is this little carbide cutter. And here's an example of it. And it doesn't really come to a sharp point. It comes to a little bit of a radius at the end. And I can show you that on this spindle. And this is a drawing of a spindle that I am working on this right now, but I've kind of drawn the tip of the cutter at several different locations, and you can begin to see that radius. So you can see 3 or 4 to 5 different locations where that is just drawn in there. that red line, this would be what we'd call the home position. This is the origin. The tool starts out, it goes here, that makes its cut, and then it backs off and then returns to home. So it's drawing a kind of a two-dimensional figure. It has a start point and it returns there. So that particular thing, we're just going to call that the tool path. And I extracted that from this program and put it in SketchUp. And here's that tool path shape. SketchUp actually has these coordinates built into it. They're in there, and our job is to get them out and make a list and use those to do the machining. So you can see that SketchUp has a much richer database than the CAD program.
But this is the spindle here. Yeah?
That's the original. It's a friend of mine this goes in the staircase to the basement of his house, and one of them was broken or missing, and this is a good one, and I use this to make the drawing.
So we'll see then how all of this works out with the handle.
Right. Well, yeah, the boat hook here is an antique that I found back when I was in college, working at a summer camp up on Lake Geneva. I found it in sort of a trash heap, and Bob has polished it up. It was kind of dented and tarnished, but it looks beautiful now. So it's an antique, going back who knows how long. It didn't have a handle on it at the time, so I gave it to Bob for his new boat, and decided to make a handle, and this is ash. The handle will have a taper on here, and then it'll get a shape to it, a nice curved shape. It'll get thinner down here where your hands are. This will be the thinnest part. I'm not doing anything with the shape at the end. When we're all done, we'll have to round that off ourselves.
So tell me about the components that you added to it to make it computer aided.
You've got a table here for what's called the y-axis that goes on this linear bearings. There's ball bearings in here, and a ball screw, and then this motor is called a stepper motor, and it moves in discrete steps, and the computer can tell it how many steps to take. So it's counting steps. That's how it controls. So that's what we call the y-axis. The other one down there's another stepper motor running the carriage. You can see this crank turning, and that moves along, and that we call the x-axis. All the wires and everything go into this control box over here, and there's the big things in there are just power supplies, and the little green boxes are the actual smarts that you buy to run this. So that's the smarts of it, and then that's attached to the computer, and you can see it's communicating with that little plug-in there. And you get this software with the. So this poor laptop was almost 20 years old, and it gave out recently. My computer technician, Tom Watkins, got it going again. He said half the sawdust in my shop was in there, and that didn't help it at all. So he cleaned it out and got things going again. So we were able to keep going. It looks like it's communicating. Started this time, and it should do something. You can see this turning. Go in that 50,000th depth, and then I've got a pause there, and it'll stop, and then I'll tell it to go ahead, and then it'll cut that.
Okay.
It takes about 1 or 2 more passes before it gets down to this diameter, and that'll be the diameter that I'll hold it at until we get all the rest of it in. And I don't know how much cutting it will do before it comes back out into the air again. We'll see about that. Pull it out and then start. Oh, it's just taking off a little bit. See, it'll come out the way.
Yeah. So this diameter here is going to be the outside diameter of that.
Right, yeah.
Okay.
And that'll come in base shape.
Yeah.
Right for you. About 50,000, yeah. Traversing the base plate and all that, I just did my best, square layout and center punch. I didn't. If you had a milling machine to start with, you could do that a lot more accurately. But it's probably good enough for what I'm doing. Boy, you got it together. Sure.
The bronze hook is all finished up now and ready to go in the boat. So the next thing is to find a home for the oar and the hook inside the cockpit. To mount the oar in the boat, I made a piece of cedar that I cut a slot in, which is the size of the blade. And so the blade will go into that slot like so, and then over on this side, I made a leather snap to fasten the oar in. I then did the same thing underneath the port seat for the hook with a couple of leather straps and snaps. Well, I've just finished tying down the last piece of lashing in order to get ready to head out to Mystic to the Wooden Boat Show. Now, I have a little update on the launch. The Mystic Seaport is not able to accommodate the needs that were required for me to launch my boat there at the seaport. So the launching is going to be on Thursday, June 27th, and it's going to be at the West Mystic Wooden Boat launch. Now, it's a very limited space there. I probably only about a dozen to 15 people would be accommodated at that location. Otherwise, at 2 p.m. on the 27th, that is Thursday, that we will be going live with the launch on YouTube. And there's a link in the description of this video that you can actually get a notification of it. Sign up for notification now. So I hope you can all join me online for the launch, and of course it will be recorded, so if you can't make it at 2 o'clock on the 27th, then you'll be able to watch it at another time. At 2 o'clock is actually high tide, which is why we're launching it at that time. The boat will then we'll move it by water over to the Mystic Seaport, and it will be on display in the water during the show. Please join us at the 32nd Annual Wooden Boat Show held at the Mystic Seaport. Our booth will be just north of the Thomas Oyster House, Land A. Skylark will be in the water in the south boat area. Several members of the Boat Building Academy that I host will have their boats and plans on display in the booth. I hope you will all be able to join us. So I'm really looking forward to it. So I will see you in Mystic, Connecticut on the 27th through the 30th. So as always, if you're going to make it beautiful.